Hello, calculus family. Today we are going to start talking about rectangles and really just get into some integrals. So this is the beginning of our fourth unit, applications and introductions to integrals. And integrals are really a way to calculate area, and that's what we're going to get into. So the first thing we're going to do is say, okay, why did anybody need to make this weird integral thing in the first place? Well, it's because we wanted to find the area under the curve. All right, so suppose we want to calculate the area between a curve and the x-axis. We could partition the region into rectangles with subintervals along the x-axis indicating our width and the value of the function representing our height. So we are going to use what's called the rectangle approximation method, okay? And there are three methods. There is RRAM, LRAM, and MRAM. RRAM stands for the right rectangle approximation method. LRAM stands for the left rectangle approximation method. And MRAM stands for the midpoint rectangle approximation method. So let me show you what that looks like. So if I want to do RRAM, and I want to split this into four rectangles, the first thing I'm going to do is make four subintervals along the bottom. So there are four subintervals. And if I do the right rectangle approximation method on this first subinterval that stretches from here to here, I'm going to use the right endpoint, go up until it hits the curve, and then go across and down. Then I'm going to take this one, go across and down, right endpoint, across and down, final right endpoint, across and down. And so I am going to estimate that area under the curve by using this area of all this yellow stuff added together. Now, is it perfect? No. I'm missing some area in the front, but I have some extra area later on, so I can deal with that. All right, and that's what RRAM would look like. If instead you were going to do LRAM, we're going to start the same way by finding my subintervals. Come here. So I'm going to break this into four subintervals. And then when I look at the interval, I'm going to start on the left-hand side and go up until I hit the curve, over and down, start here, go over and down, start on the left, go over and down. So notice how I'm using the left endpoint of each subinterval, drawing up until I hit the curve, and then going over and down. Now, if I looked at these together, I would say RRAM seems to overestimate this area, and LRAM seems to underestimate this area, because if I shaded that in to make it a little bit more obvious here, LRAM really only goes outside for that one little part, and then it stays inside a lot more than it goes outside. So LRAM is probably an underestimate. Now, what about MRAM? If L and R aren't perfect, maybe MRAM will be better. Let's find out. So I am again going to split this into four subintervals. And now, between this subinterval right here, I'm going to grab the midpoint of the interval and then go up to hit the curve and go straight across and down. Take the midpoint right here, straight across and down, straight across, and straight across. And what's nice about MRAM a lot of the time is that you kind of have an over and an under for each of the rectangles. Because if I look at this one, it's outside a little bit and inside a little bit. This one kind of the same way, outside a little bit, inside a little bit, kind of same thing here. Okay, so of those four, which one looks like it's the best? MRAM definitely looks like it's the best, and I'm going to be honest, between LRAM, RRAM, and MRAM is often the best one to use, but sometimes it's hard to use MRAM, so we're going to have to kind of pick and choose depending on what I tell you to pick and choose, and what's available for you to use. All right? So, is it clear from this exercise which rectangle approximation method is the best? We're going to say probably MRAM. Now, what can we do to better estimate the area under the curve? Well, I mean, maybe not using rectangles because they're not great, but what if I say you have to use rectangles? What could I do with these rectangles to better estimate the area? Let me give you a hint. Doesn't that look a lot better than the original one? Yeah, we stay closer to the curve. Now, what did I do? Instead of using 4 rectangles, I used 8. This is definitely a lot better if we use more rectangles. Okay, cool. Now, you're going to use however many rectangles I tell you, but you should know that the more rectangles you use, the better. But there comes a point where you have to say, okay, my sanity is also important, and I'm not going to do 48 rectangles because that's going to be obnoxious. So we do whatever we need to do to get as close as is practically possible without going insane. Or you just do whatever I tell you to do. So example 2 says, draw and use 4 rectangles to estimate the area between f of x equals x squared minus 2x plus 2 and the x-axis on the interval from 1 to 3. Use RRAM, LRAM, and MRAM. Show the calculations that lead to your answer. Okay, so I am going to only think about the interval from 1 to 3. So the area that I'm really interested in is this area here, and I'm going to try to shade it as best I can here. This is the exact area that I'm looking for. But I know I'm not going to be exact because I'm going to use rectangles. So if I'm supposed to use 4 rectangles on the interval from 1 to 3, well, let's see. Oh, Mrs. Vibber made a goof. I went from 0 to 3. See, look. I got to be more careful. 1 to 3. There we go, Mrs. Vibber. 1 to 3. Da-da-da-da-da-da-da. I could delete these times where I make a mistake, but I want you guys to understand that we all make mistakes. I definitely make mistakes, and you can too. Just try to notice when you do. All right, so there's the interval from 1 to 3, and I'm supposed to break that into 4 rectangles. Okay, well, that'd be 2 rectangles. And if I split it into 4 subintervals, it would look like that. And if I'm going to use RRAM, I'm going to use the right endpoint of each subinterval to draw my rectangles. Okay, so there are my rectangles. They're a little bit tippy, but that's okay. And they want us to actually estimate the area. So we're going to do some calculations now. So if I wanted to find and estimate that area, I would need to add the areas of those 4 rectangles together. Well, this rectangle started at 1, and it went up to 1.5. And I used 1.5 to find the height. So for rectangle number 1, the area of a rectangle is base times height. The base of my rectangle is 1/2 wide, and the height of my rectangle is f of 1.5. All right, now, the calculator that I would normally use on the screen is not working, so I'm going to type it off to the side here, okay? And what I'm going to do is in y equals, I'm going to type x squared minus 2x plus 2, and then I'm going to evaluate that on the screen of the calculator. So I am going to do f of 1.5 and get 1.25. So my first rectangle is 0.5 times 1.25, which, if I'm not mistaken, is 0.625. Not 7, 625. Why did I write a 7? Who knows? Okay, and now rectangle number 2 would also have a base of 0.5, and its height would come from this value, which is 2. So I'd have 0.5 times f of 2. And if I type that into my calculator, I get 1. And then the third rectangle would be 0.5 times f of 2.5. This is a lot better if you can see it on the screen, but you can't, so we'll have to deal with it. 1.625. And the fourth rectangle still has a base of 0.5 and a height, which is f of 3, which is 2.5. So my area estimate is the sum of all those. And I think that area is approximately 5.75. Here's the thing, that was a lot of writing, right? And my widths were always the same on the bottom. So there was a quicker way to do that. What I could have done is just said, well, it's going to be 0.5 times f of 1.5 plus f of 2 plus f of 2.5 plus f of 3. Let's use that for the next one. So if I want to use LRAM now on the interval from 1 to 3, I'm still going to break it up into my subintervals, but now I'm going to use the left endpoint when I draw my rectangle. So this one's going to be an underestimate. All of my widths are 0.5, and my heights start at 1, so I use a height at 1, then I use a height at 1.5, then I use a height at 2, then I use a height at 2.5, and I never use 3 because I'm using LRAM. So this would be 0.5 times f of 1 plus f of 1.5 plus f of 2 plus f of 2.5. So if I do the same thing as I did the last time, I am really just going to end up with, I'm going to press pause so you don't have to wait. No, I'm not. It's not working. You just have to wait. So if I do it in my calculator, I have 0.5 times, let's see, f of 1, 1.5, 2, 2.5, and I get 3.75. And that makes sense that RRAM is bigger than LRAM because RRAM is obviously outside, it's an overestimate, and LRAM is inside, it's an underestimate. Now, MRAM should be somewhere in between there. So if I use MRAM this time, I'm going to zoom in a bit. I'm going to break this up into my 4 subintervals. But remember, to get MRAM, I got to go in the middle of the subinterval and go straight across and down. So if this is 1 and this is 1.5, that's 1.25. This would be 1.75. This would be 2.25. And this right here would be 2.75. All right, so I'm going to try something here because my TI calculator isn't working. Let's just use Desmos because Desmos is amazing. So if I come in and use my Desmos calculator instead, my function is x squared minus 2x plus 2. And if I want to find the area for MRAM, I know my area. All my widths are still 0.5, and now I'm multiplying by f of 1.25, and f of 1.75, and f of 2.25, and f of 2.75. All right, so I am going to put that literally just like that into Desmos. So 0.5 times f of 1.25, nope, not 24, plus f of 1.75, plus f of 2.25, plus f of 2.75. 4.625. Cool. And if we look at that, that seems to be in between the other two. Now, is MRAM exactly in between RRAM and LRAM? No, because between 4.75 and 3.75 should be 4.75. We got 4.625. This is not exactly in between LRAM and RRAM. It will be between them most of the time, but it won't be exactly in between them. All right, so I feel like this video has gotten a little bit long, so I am going to stop here and hope that this LRAM, RRAM, MRAM stuff is making sense to you. And then we are going to move into the other examples afterward. So I hope everybody's having a good day and continues to do so. We will talk again soon.